So, changing from degrees to radians. There are two formulas you need to know. One, to change from degree to radian, you need to multiply the degrees, so the theta times pi over 180 degrees. Okay, so this is radians. So this is from degrees to radians. Okay, what about radians to degrees? Well, we take our theta, we multiply it by 180 over pi radians. Okay? So, this is just the relationship in pi radians equals 180 degrees. Okay? Okay. So this is what we're originally going to look at. I'll give you some practice problems to practice it. So transferring an angle to radians from degrees, and from radians, from degrees to radians, and from radians to degrees. Okay. Okay. So I'll give you a bunch of practice problems. Don't worry about it. Okay, let's move on. Arc length. Let's just blow this up so that this will fill the screen. Okay, so arc length is going to have a relationship to our radius. So let's zoom out a little bit. Okay, so for a circle of radius r, a central angle theta intercepts an arc of length s, given by the formula s equals r theta. Okay? Where theta is measured in radians. Okay, so sometimes we'll give you the degrees of the angle, so you have to change it. Note, if radius equals 1, then s equals theta, right? If radius is 1, then, and the measure, and the radian measure of theta equals the arc length. Okay, that's going to be important sometime later. So if you have a circle, so this is example 5, if you have a circle 4 inches with radius 4 inches, so let's just take this back. Okay, so let's say we have a circle with a radius of 4 inches. And we have a central angle of 240 degrees. What we're going to do is we're going to first 240 times pi over 180, and what we're going to get, let's just cancel. So it's going to be 4 pi over 3 is going to be our angle. This is theta. So then we're going to do 4 times 4 pi over 3. So our answer is is going to be 16 pi over 3 inches is going to equal S. And in that case, that's going to be correct. Now, do you have to get exact answer? Yeah, this is actually exact answer, okay? Okay. Linear and angular speed. We're going to go through this a little bit quickly. So linear speed is going to be the speed along the wheel. Like if you have a wheel turning, right? So imagine you're a point on a wheel and you're spinning around really fast. Think of it as like a nail within a tire, okay? And it's spinning around really fast. The linear speed is how fast, if you were to measure that distance out, how fast it would be moving straight. So, linear speed equals so V equals S divided by T. So this is arc length divided by time. Now, angular speed is going to be omega. This is the degrees per second. So your linear speed could be really fast, but your angular speed could be slow. If it's a huge wheel and the wheel's turning, the angular speed is going to be slower, but the linear speed is going to be faster. There's actually a conservation of angular momentum, and that's actually going to connect to this formula. Okay? So linear speed is going to be the arc length divided by time. Angular speed is going to be the degrees divided, the angle divided by time. So this is in the book. You can look it up. You do want to change your degrees into radians, okay? All these things, degrees into radians. Okay, angular area of a sector. The formula for area of a sector is going to be quite important. So it's going to be A equals 1/2. This might remind you. Radius squared times theta. So pi r squared, pi is going to be the angle. R squared is going to be, so if you actually applied this to a full circle, the angle of full circle is 2 pi. So 2 pi times 1/2 is going to be pi. Pi r squared is the area of a circle. So this area of a sector is going to apply to even if we're finding out for a circle, okay? Okay, we're gonna move on to unit circle. Now, unit circle, we're going to spend some part of the time. A unit circle is a circle with the formula, okay? X squared plus y squared equals 1. So it's a circle with radius 1 found centered on 0, 0, okay? Okay, this is what we're going to apply to our 6 trig functions. What are our 6 trig functions? Well, 6 trig functions are sine, cosine, tangent, then the ones related to sine, cosine, tangent, cosecant, which is related to sine, secant, which is related to cosine, and cotangent, which is related to tangent. So, if we have the unit circle with, okay, this is 1 comma 0, 0 comma 1, this is negative 1 comma 0, and this is 0 comma negative 1. Okay, so if we have our unit circle and we have an angle, and our angle is going to be theta, but this point is going to be t. Okay, this is the theta. Now, if we take it of a point on the unit circle, if we're doing this, this is going to equal our y. cosine of that point is going to be the x value of that point. X comma y. Tangent of that point is going to be equal to y divided by x. Cosecant of that point is going to be 1 over y. And then cotangent of that point is, secant is going to be 1 over x. Cotangent is going to be x over y. Notice, we just, for the unit circle, this is for a unit circle. This applies. If you have an angle, you have a point, that angle hits the circle. The sine's going to be your y value. Cosine's your x. Tangent's y divided by x. Cosecant is 1 over y, and secant is 1 over x. And then cotangent is x over y, okay? Now remember, if we're dividing by this, x can't equal 0 for tangent, just as y can't equal 0 for secant. X can't equal 0 for, cosecant. Y can't equal 0. Secant x can't equal 0, and then cotangent y can't equal 0, okay? So those are our rules, okay? Now I want you to pay close attention because we're going to do some exercises with this in class, okay? Okay, you're going to find the angle, you're going to find, evaluate the 6 trig functions for the real numbers. T equals pi over 6, t equals 5 pi over 4, t equals 0. We're going to fill in a unit circle together. I will have you guys memorize it because it is very useful for the rest of this class. So we're going to practice these parts in class, okay? Okay.